Hi students, it's me, D. Kritika, Assistant Professor, Department of Chemistry, K.S.Rangasamy College of Technology. Today we are going to see the topic in Module 1, that is Water Technology. Here, the how the water gets treated. So there are two processes are there, internal treatment, external treatment. So here we are going to see about the external treatment otherwise we can tell as a conditioning method for hard water. Here there are two major methods are there. One is zeolite process, another one is demineralization process. So demineralization process, it shows that it is removal of all the minerals from the water. So mostly we will tell as a removes almost all cations and anions from hard water. So that water does not contain any ions over there. So for this process, we are using ion exchange resins. So how the ion exchange resins were prepared and what is the property of that ion exchange resin? It is long chain and cross-linked. It is a long chain compound. Mostly the polymers will be used. Then cross-linked compounds in inorganic polymers. Mainly it will be insoluble in water. So that we are telling as it is a resin. Then here the functional groups on resins enable the ion exchange. For example, if it is a cation exchange resin or anion exchange resin, we are using cations or anions. Okay. Then we are going to see about the advantages and disadvantages in this method. Okay, let me move on to cation exchanger. So cation exchanger, what are the properties of that cation exchanger resin? Is that it contains acidic groups. What is the acidic group? This is an COOH. This is organic acidic group. Okay. And this one SO3H. This is sulfuric acid. That is, it is inorganic acids. So it contains these acidic groups. Either organic group are present or inorganic groups are present. And also why we are using this acidic group means it exchanges H plus ions with the cations. So we know that the water contains calcium, magnesium and sodium. So our aim is to remove the calcium, magnesium, sodium, the hardness causing ions. So here this H plus ions will replace that Ca2 plus, Mg2 plus and Na2 plus. Na plus. Okay. So here generally we can represent this acidic group with that metal, that is with that ions we call as a RH. So what are the examples of this cation exchanger resin, or that it is a resin? So we are taking sulfonated coal, sulfonated polystyrene, that is RSO3H and RCOOH. We know that this carboxylic acid is present over here. This sulfuric acid is present. So sulfuric acid presented compound. Okay. Here the R may be any group, alkyl group or any aryl groups. Clear? Okay. Then we move on to anion exchanger resin. So same as that of cation exchanger resin, anion exchanger resin, it contains a basic groups. So NH2, that is amine group, and OH group. This is that is a alcoholic group. Okay. So it exchanges this OH minus ions with the anions. What are the anions present in water? Chlorine, sulfates and carbonates and bicarbonates. Okay, so these all ions can be removed by replacing of the OH minus ions. So we are telling as an anion exchanger resin. So here the notation can be given by ROH. Okay, what are the examples which is given over here is cross-linked quaternary ammonium salt, then urea formaldehyde resin. So what is a cross-linked quaternary ammonium salts? We know that ammonium salts, no, so that is cross-linked. Quaternary ammonium salts are used as an anion exchanger resin. And then other compounds which we use as an anion exchanger resin are urea formaldehyde resin. So R, NR3OH, ROH, RNH2. So primary amine can be also used, or any other that is alkylated amine can be also used. The R group may be aryl or alkyl groups. Then we move on to how the reaction gets flow on. So we are having a two chambers. That is, first chamber, it has an cation exchange resin. So mostly our aim is that we have to remove Ca2 plus, Mg2 plus and Na plus. So what are the reactions which taken place in the first chamber? That is, we are having a RH group over there. When yeah, CaCl2, it is from water, it will react with that RH to form RCA. It will be deposited on the resin. It will be deposited on the chamber. Okay. Then we are getting HCl. This will be run off into the water to the next chamber. So likewise, we are having magnesium sulfate, RMG and H2SO4, and RH same, as well as it reacts with NaCl to form RNA plus HCl. And then we move on to anion exchange resin. So that in that second chamber, we are using anion exchanger that we represent as ROH. Here it removes Cl2 minus and SO4 2 minus and H3, that is bicarbonate ions. These ions can be removed. These are anions present in the water which comes from the first chamber. So what is the reaction which taken place over there? That in that chamber ROH, we are having the HCl which is coming from the water will react with this ROH to form RCl. Okay, plus H2O. So then other reaction also, it shows that formation of water. So we are getting the pure water over here. Okay. Then we know that once a period, it will be exhausted, the reaction will be completed, so that we have to regenerate the resins. So for cation, we have to cation resin is used over there. Here regeneration using dilute HCl or H2SO4. H2SO4 or dilute HCl can be used for the regeneration of RH, so that we are regenerating this RH for the next process. As well as the cation resin, we have to regenerate for anion resin. So generated using dilute NaOH. So same reaction, that is the RCl2 which is present over there will react with sodium hydroxide to form ROH. So we have regenerated this RH and also this ROH. Then see the diagram. This shows the how the reaction or how the process have been carried out. So the raw water is it gets into this first chamber. This is RH, that is cation exchange resin. So it contains calcium sulfate, sodium chloride, any all type of ions. Here this RH reacts and RCA will be formed. So the water comes over here will have only the cations. Okay, this cation will move upon to the second chamber. In the second chamber, we are having ROH ions. This ROH ions will replace the sulfate and chloride, so that after this chamber that we are getting a pure water over there, that we called as a demineralized water or deionized water. So this cation exchange column, this anion exchange column is explained over there. Here this dilute HCl is used for regeneration of cation exchange resin. Here dilute NaOH is used for anion exchange resin. So what are the advantages of this process? It produces very low hardness water, treats highly acidic or alkaline water. What is the disadvantage? That is, it is a high equipment cost and it requires hazardous chemicals. So these are all the disadvantages and advantages of the demineralization process or ion exchange process. Okay, thank you all.